The thread class in Java has a sleep method which we can use for pausing the execution of a thread. With this, we can simulate a long-running operation, like downloading a file that takes a few seconds. So in our task class, after printing this message, let's call thread.sleep. Here we can pass the delay in milliseconds, let's say 5,000. So this will suspend the current thread for roughly 5,000 milliseconds or 5 seconds. It's not going to be exactly 5 seconds because this is dependent on the underlying operating system. But we can assume that this thread will be sleeping for roughly 5 seconds, and during this time, other threads can get processor time. Now, the Java compiler is complaining that we have an unhandled exception here. That is interrupted exception. This is an exception that gets thrown if you try to interrupt a thread that is sleeping. We'll talk about interrupting a thread later. But for now, let's handle this exception. So we put the caret on this sleep method, press Alt and Enter, and wrap this inside a try-catch block. Pretty easy. Now, after 5 seconds of delay, let's print another message like download complete. We can also add the thread name for clarity. So plus thread, that current thread, that get name. Now, back to our demo class. Here we are starting 10 threads for downloading 10 files. When I run this program, you will see that these 10 threads will start at the same time. And after 5 seconds, they all complete. Take a look. So run. They all started. Now 1, 2, 3, 4, and 5. They're all complete. Now, if you had a single threaded application, downloading these 10 files would take 50 seconds instead of 5 seconds because each download would start once another download finished. So multi-threading makes our applications faster and more responsive. Now, what if we try to download, let's say, 100 or 1,000 files concurrently? My machine has 4 cores and 8 threads available. So how's that going to work? Well, the Java virtual machine has what we call a thread scheduler. The job of this scheduler is to decide what threads to run for how long. So if you have more tasks than the available threads, the scheduler switches between these tasks, giving each a slice of the CPU time. This happens so fast that gives us the illusion that these tasks are being executed in parallel. But that's parallelism at software level.